252 million years ago, Earth's oceans reached temperatures of 40 degrees Celsius or 104 degrees Fahrenheit. That's hotter than a hot tub. For nearly 60,000 years, the Permian period ended not with an asteroid impact, not with volcanic eruptions alone, but with a global ocean heat wave that killed 90% of all marine species. Paleontologists called it the greatdying. Then a 2023 study from the University of Bremen proved the extinction wasn't just about heat. The oceans became toxic soup that dissolved shells, suffocated fish, and turned the entire marine food web into a death spiral nothing alive today could survive. Modern ocean heat waves kill coral reefs and stress marine life over weeks or months. Not to worry though, the Permian heat wave lasted 60,000 years and raised ocean temperatures by 10 degrees Celsius or 18 degrees Fahrenheit globally. You couldn't migrate to cooler waters because there were no cooler waters. Every ocean on Earth became a killing zone simultaneously. The trigger was the Siberian Traps, a volcanic event so massive it makes Krakatoa look like a firecracker. Magma erupted across an area larger than Europe, covering 7 million square kilometers or 2.7 million square miles with lava flows up to 3 kilometers or nearly 2 miles thick. These weren't normal eruptions. They lasted over 300,000 years, pumping trillions of tons of carbon dioxide and methane into the atmosphere. Scientists knew about the Siberian Traps for decades. What they didn't understand was the mechanism that turned volcanic gases into ocean apocalypse. A 2019 study from MIT examined rock layers from the Permian-Triassic boundary in China. The rocks contained chemical signatures revealing atmospheric carbon dioxide levels reached 2,500 parts per million, over 6 times higher than today's levels. That CO2 didn't just warm the air. It dissolved into the oceans through a process called ocean acidification. When CO2 mixes with seawater, it forms carbonic acid. This acid attacks calcium carbonate, the mineral that builds shells, coral skeletons, and the protective structures of thousands of marine species. Unfortunately for Permian marine life, their shells started dissolving while they were still alive. Shockingly, the acidification happened in just 10,000 years, a geological eye blink. Marine species that took millions of years to evolve calcium carbonate shells watched those shells disintegrate in mere generations. Trilobites, which had survived for 270 million years through multiple extinction events, went extinct because their exoskeletons couldn't handle the acid bath. But here's what makes it worse. The warming oceans triggered a feedback loop that intensified the crisis. Warmer water holds less dissolved oxygen than cold water. As ocean temperatures climbed, oxygen levels dropped. Scientists call this ocean anoxia, the complete absence of oxygen in seawater. A 2021 study from Stanford University analyzed sulfur isotopes in Permian sediments from 6 continents. The isotopes proved that oxygen levels in shallow coastal waters dropped by 80% within 20,000 years. Deep ocean oxygen disappeared completely. Fish that survived the initial warming and acidification suffocated as oxygen levels crashed. In case you needed more proof, researchers found preserved biomarkers, molecular fossils from purple sulfur bacteria. These bacteria only thrive in oxygen-free water rich in hydrogen sulfide, the same hydrogen sulfide that smells like rotten eggs and causes immediate death in humans at concentrations above 1,000 parts per million. Permian oceans had concentrations exceeding 5,000 parts per million in many regions. You couldn't even escape to surface waters. Hydrogen sulfide isn't just toxic in water. When it reaches high enough concentrations, it bubbles into the atmosphere. A 2020 study from the University of Washington proved hydrogen sulfide gas reached toxic levels in coastal air during the extinction's peak. Marine animals that survived acidic, oxygen-depleted water faced toxic gas when they surfaced to breathe. The temperature increase alone killed species faster than evolution could adapt. Modern fish can adjust to temperature changes of 1 to 2 degrees Celsius over multiple generations. Permian oceans warmed by 10 degrees in 10,000 years. Species adapted to cold, deep water watched their habitats become uninhabitable as warm water expanded from the surface downward. Talk about nightmare fuel. The deep ocean, traditionally a refuge during surface extinctions, became a death trap first. Cold water species had nowhere to retreat. Then researchers discovered the truly terrifying part. CT scans of Permian fish fossils from South Africa revealed something unprecedented. The bones showed growth rings indicating these fish reached sexual maturity in 6 to 8 months instead of the normal 2 to 3 years. They were breeding faster and dying younger. This pattern appears across dozens of Permian species. The extinction created what scientists call survival mode reproduction. Organisms burned through life cycles rapidly, trying to adapt through accelerated generations. It didn't work. The environmental changes outpaced even accelerated evolution. The marine food web collapsed from the bottom up. Phytoplankton, microscopic algae that form the base of ocean food chains, died first. These organisms need specific temperature ranges and water chemistry to photosynthesize. When conditions shifted outside their tolerance, phytoplankton populations crashed by 95% globally. No phytoplankton meant no food for zooplankton. No zooplankton meant no food for small fish. No small fish meant no food for large fish. The entire pyramid collapsed in less than 100,000 years. Modern ocean food webs contain hundreds of species at each level, providing redundancy. Permian oceans had similar complexity, but when the foundation died, everything above it followed. Unfortunately for filter feeders, the situation got worse. Many marine species survived by filtering plankton and organic particles from water. But acidic, oxygen-depleted water contained different particles: toxic minerals, dead organic matter, and bacteria that produced hydrogen sulfide. Filter feeding became self-poisoning. Brachiopods exemplify this tragedy. These shelled organisms dominated Permian seafloors, with over 1,000 species occupying every marine environment from tide pools to deep ocean. They filtered plankton through specialized organs, thrived for 300 million years, and seemed invincible. The Permian extinction killed 95% of brachiopod species. Today, fewer than 450 species exist, all in marginal habitats. Shockingly, some organisms actually benefited from the extinction. A 2022 study from the University of Bristol examined microbial mat fossils from Permian-Triassic boundary rocks. These mats, layers of bacteria and algae, hadn't dominated seafloors since before complex life evolved. The extinction killed so many shell-bearing animals that microbial mats reclaimed ocean floors for 5 million years. In case you needed more proof of how completely the extinction reset marine ecosystems, coral reefs disappeared. Not just damaged, completely gone. Reef-building corals went extinct globally. It took 10 million years for new coral species to evolve and rebuild reefs. That's longer than the entire time humans and their ancestors have existed. The geographic scope makes recovery even harder to comprehend. The extinction wasn't limited to one ocean or one region. Every marine environment on Earth suffered simultaneously. Shallow tropical reefs died, deep ocean trenches died, Arctic seas died, Antarctic waters died. There was no refuge, no safe harbor, no isolated population that could repopulate devastated areas. No modern extinction compares to this scale. The Cretaceous asteroid that killed the dinosaurs was more sudden but less thorough. 75% of species died versus 90% in the Permian. The current climate crisis causes localized die-offs but not simultaneous global ocean death. The Permian extinction stands alone as the most complete biosphere collapse in Earth's history. A 2023 study from the University of Bremen synthesized decades of research into a comprehensive timeline. The volcanic eruptions began 300,000 years before the extinction peak. CO2 levels climbed steadily, warming oceans and acidifying water gradually. Then around 252 million years ago, the system hit a tipping point. Methane hydrates, frozen methane trapped in ocean floor sediments, began melting as water warmed. This released massive amounts of methane, a greenhouse gas 25 times more powerful than CO2. The methane release accelerated warming, which melted more hydrates, which released more methane. This runaway feedback loop pushed ocean temperatures to lethal levels within 10,000 years. You couldn't adapt to changes this rapid. Species that survived the initial warming faced acidification. Species that survived acidification faced anoxia. Species that survived anoxia faced hydrogen sulfide poisoning. And every survivor faced a collapsed food web with no prey and no habitat. The extinction had multiple killing mechanisms operating simultaneously. The fossil record preserves the desperation. Rock layers from the extinction period show mass mortality events. thousands of individuals dying together in confined areas. These weren't predation events or natural disasters. These were entire populations suffocating or poisoned simultaneously as conditions shifted beyond survivability. Then there's the time factor. Modern species face environmental challenges over decades, potentially enough time for migration or adaptation. Permian species face catastrophic changes over millennia, too fast for adaptation, too slow for any population to outlast the crisis. The extinction timeline was perfectly calibrated to maximize death. Unfortunately for paleontologists trying to understand recovery patterns, the extinction's aftermath was almost as bad as the event itself. Rocks from the early Triassic, the period immediately after the Permian, show continued environmental instability for 5 million years. Ocean temperatures remained elevated, acidification persisted, anoxic dead zones expanded and contracted unpredictably. Life eventually recovered, but the survivors were fundamentally different from what came before. Brachiopods never regained dominance. Trilobites never returned. The organisms that rebuilt marine ecosystems were newcomers. Species that evolved during or after the extinction from survivors adapted to harsh conditions. Modern ocean biodiversity descends from these crisis-adapted species, not from the Permian marine giants. That's the reality of the Permian extinction. Not a quick asteroid impact that reset the clock. Not a volcanic winter that killed through cold and darkness. But a 60,000-year ocean heatwave that killed 90% of marine species through acidification, anoxia, toxic gas, food web collapse, and temperatures that dissolved shells and suffocated fish. Scientists called it the greatdying. The evidence proved it was worse than anyone imagined, and recovery took 10 million years because there was almost nothing left to recover from.